Namaste. This video is going to be about the solution of the Electronics and Communication GATE paper of 2014 set 3. The subject related is mathematics and the question was asked for 1 marks. So let's see what the question was. The question says match the following application to appropriate numerical methods. So on one side you have the numerical methods given, and the other side of the column you have the applications where they are used. Okay, and you need to match which of the following numerical method is used in which of these applications. So to solve this question, the reference would be any graduate level course on numerical methods which is studied by a particular course in BTech in second or third year of mathematics, and the other source can be any NPTEL videos on the course on numerical methods. Okay, these two will serve as a reference to this particular solution. I am not citing any particular lecture as a reference because you have different methods here which are being dealt. So these methods are dealt in the entire course length of the numerical methods course, and therefore one lecture will not suffice. So the concept required is to just have awareness about various methods which are used to solve different types of problems numerically. So what I'll do is I'll highlight most of the majority of the algorithms or applications to solve numerical problems. So the first form of problem is integration. So in integration we can use midpoint method to solve it numerically. Midpoint method, I'll just name out the methods here, and then you have trapezoidal rule or trapezoidal method, and after trapezoidal rule you have Simpson's 1/3 and Simpson's 3/8 rule. Simpson's rule are of two types, 1/3 and 3/8. So these particular methods can be used to solve numerical integration or to solve integration problem numerically. There are these three methods which I am pointing out. Transcendental equation, you have a many methods. The first of which is bisection method or the midpoint method, bisection method, and then you have Ryder's method or Ridder's method, whatever you want to call it, Ridder's method, and then you have Newton-Raphson method. Newton-Raphson is there to solve transcendental equations, Newton-Raphson, and then you have staircase or iterative method, staircase or it's also called iterative method, and then you have second method or the Newton's method, Newton's second method. So these methods are there to solve the transcendental equations. Then you come down to differential equations, and then you have many methods to solve these differential equations numerically, them being Picard's method, Picard's rule. Then you have Taylor series method to solve the differential equation numerically, or you have Euler's method. Then you have modified Euler's is also there, and then you have Runge-Kutta method. Okay, so all these methods are there to solve differential equations numerically. And then coming down to linear equations, again you have many methods. For example, Jacobi method to solve numerical linear equations. Then Gauss-Seidel is there, Gauss-Seidel method, then you have conjugate method. Some of these methods won't be in the GATE syllabus, but I'm listing out many methods that are existing to solve these type of problems. Okay, then you have Gauss-Jordan method or Gauss-Jordan elimination method, whatever you like to call Gauss-Jordan. Then LU factorization is there, and then there is another method called successive over relaxation or SOR, successive over relaxation method. So these methods are used to solve linear equations numerically. So now, having known all these methods to solve particular kind of problems, we can directly have a matching. So of course, as we have seen, Simpson's 1/3 rule will be used to solve numerical integration. Cool. Solution to transcendental equation. Transcendental equations are being solved by Newton-Raphson. So this is there. So for now we have the sequence as P1 for M3 and P2 for M1. Then solution to systems of linear equations will be given by Gaussian elimination method or Gauss elimination, which is P3 M4, and therefore solution to differential equation will be given by Runge-Kutta method, which is pointed out here. Okay, and we have already seen that here differential equation Runge-Kutta method is outlined. So As far as our answer goes, it is M3, M1, M4 and M2. P4 goes to M2. So we'll just match this sequence out. We see that this particular sequence is satisfied in option B, M3, M1, M4, M2, and therefore the correct answer for this particular question is option B. This is a memory based question and I hope the solution was clear. Thank you.